How are you guys? Welcome back to my channel. I'm Charles Alena. Welcome back to my channel called Applied Science College. Today we are going to continue with our series of chemistry. Now we are going to Titration Practical 4 and we are going to demonstrate how practical of titration is done. It's just a demonstration, but I hope we will be able to understand each other in as far as these practicals are concerned. You are provided with solution P containing 12 grams of mixture of sodium carbonate and sodium chloride in 1 liter, 0.1 molar sulphuric acid solution, metal orange indicator. You are required to determine the percentage purity of sodium chloride and sodium carbonate in the mixture. The concentration of solution in moles per liter in terms of sodium carbonate, the molarity of the solution in terms of sodium chloride. Procedure. The procedure is here. Using a pipette, transfer 25 cubic centimeters of solution P into a clean conical flask. Add 2 to 3 drops of methyl orange indicator. Then you fill the burette with the solution W. Titrate the solution P with W from the burette and record the results in the table below. So now this is our table. We are going to tabulate our results here. We have the final burette reading in terms of cubic centimeters, initial burette reading in terms of cubic centimeters, and the volume of solution W used. So now we are going to assume maybe we have carried out our titration properly and accurately with those respective solutions, and maybe let us assume that our initial burette reading was 0.0. So now 0.0, it means now we have titrated, then we assume now it changed at 25.0, and then we refilled the burette. And then it changed at, for example, let us say just 21.1. Then we refilled the burette up to the zero mark. So we restart our titration on our second column of this titration table. So now maybe we say we have titrated, and then it changes at around 25.2. Then we refill the burette again up to the 0 mark. So we are going to have our initial volume at 0.0. So now it brings, then we titrate, our end point comes to at around, let us say 25.0. 25.0 like that. So if we want to get the volume of the solution W used, we subtract this from this. If final from the initial, we get 25.1. Like that. Also in column 2, we subtract the initial from the final, which is 25.2, and then we subtract 0, we get 25.2. The same thing to column 3, so we get here 25.0. So we go back to our equation, to our questions. What does the question require us to do? What are the questions asking? For example, in our A, determine the volume of solution of the solution W used. So we are going to determine the average volume of solution W used. So we are going to say the average volume of solution W used, which is sulphuric acid, is going to be equals to first titer plus second titer plus third titer volume. Everything that is supposed to be in cubic centimeters. So we are going to substitute. We get the first reading at 25.1 plus this 25.2 plus 25.0. Everything is supposed to be divided by 3. So if we do our calculations properly, We go back to our calculator and then we get 25.1 plus 25.2 plus 25.0. So the answer is that we are getting is 75.3 divided by 3. So we are going to divide this one by 3, which is our average volume is 25.1 cubic centimeters. So we go to question 2. Question 2, we are told to determine the number of moles of solution W. Determine the number of moles. Determine the number of moles of solution W. Of solution W. So now in this case, we must write the equation first. We are going to equate this way. The number of moles is equal to molarity times volume. Number of moles is equal to molarity times the volume. Remember, our solution W is here, and we have this average volume. So the number of moles is equal to, we substitute here. The molarity of W we have been given here, it is 0.1. So we write here 0.1 times the volume. This is the volume that we got, the average volume. So we are going to use the average volume, 25.1. 25.1. We go back to our calculator here, which is giving us 0.1 times 25.1, which is giving us, if you do your calculation properly, sorry, the molarity is supposed to be 0.1, we multiply by the volume, and then we multiply we divide by 1,000. Beg your pardon, because we divide by the molarity, we multiply by volume here, and then which is supposed to be molarity here, the molarity 0.1 times 25.1, we divide by 1,000. So all in all, we come back to our calculator here, because this 0.1 is the molarity, and the molarity is always it's supposed to be divided by 1,000. The number of moles in 1,000. So it's going to be 0.1 times 25 divided by 1,000, which is giving us 0.0025 moles. Good. If you do your calculations properly, you will get this. So we have been asked, determine the number of moles of sodium carbonate in solution P that reacted. Determine, we are supposed to do 1, 2, 3. We have been told, determine the number of moles of sodium carbonate. Determine the number of moles of sodium carbonate that reacted of sodium carbonate in solution P, of sodium carbonate in solution P, of sodium carbonate in solution P. in solution P. These short remarks, in the process, in the long run, we must approach it this way. Here, we must write the chemical equation first. So, we are going to write the chemical equation. Sulphuric acid plus sodium carbonate. It's going to give us sodium sulfate plus sodium sulfate plus carbon dioxide plus water. So we need to ask ourselves, is our equation balanced? So we are supposed to consider the reactant side and the product side, because when you react sulphuric acid plus sodium carbonate, you get sodium sulfate plus carbon dioxide plus water. So in this case, we are supposed to also consider, we are supposed to go ahead and find out, is our equation balanced? Our equation, let us consider hydrogen. Hydrogen are 2 here. On this side are 2. Sulfate is 1, this side is 1. Oxygen, how many oxygens do we have on the reactant side? 0.4. On this side, we have 4 oxygens. Also this side, we have how many oxygens? We have here on the reactant side, we have 4 oxygens plus 3. These ones are 7. So on this side also we have 4 plus this. So they are all 7. The oxygens are balanced. So in this case also we go on the reactant number 2. We find out that sodium, we have 2 sodiums here. Also we also have another 2 sodiums on this side. Carbon, we also have carbon there. Oxygen, we have seen oxygen is balanced. So the mole ratio here, we write here the full equation. Sulphuric acid plus sodium sulfate. It's supposed to give us sodium sulfate plus carbon dioxide plus water. This is liquid, this is gas, this is aqueous, this is also an aqueous, also this is an aqueous. Mole ratio here, mole ratio is 1:1. Our equation is balanced. And what is the equation asking? Determine the number of moles of sodium carbonate in the solution, in solution P. The number of moles in solution P, we are going to ask ourselves, because the volume here is 25.1. Here, the volume here, it is 25.0. So we have been asked to calculate the number of moles of sodium carbonate in solution P. In this case, because of the mole ratio is the same, now the number of moles are going to be the same as this, the same as the ones that are the cells are in the sulphuric acid. So due to mole ratio, we write here due to mole ratio being 1:1. The number of moles of sulphuric acid is 0.0025 moles. Hope we are together up to that point. So we go to question number, this is question 1, 2, 3. We go to question 4. We have answered question 3 because of the mole ratio. It is the same, 0.025. The mole ratio of sulphuric acid and sodium carbonate is 1:1. So the number of moles here, they are just equal. They are the same as this. I hope I'm very clear. So we go to question number 4. Question number 4. Determine the concentration in moles per liter in terms of sodium carbonates, determine the concentration in terms of sodium carbonates. Sodium carbonates. So in this case, we are supposed just to ask ourselves, if 25, here it's supposed to be sodium carbonate. So here it's supposed to be sodium carbonate. So if sodium carbonate it has given us this sodium carbonate. Now, if 25.0 cubic centimeters, we have this number of moles, 0.0025 moles. What about in 1,000 cubic centimeters? So we are going to cross multiply here. 1,000 times 0.0025 divided by 25. All this is the molarity or concentration of sodium carbonate. So we go back to our calculator. 1,000 times 0.0025 divided by 25. So we have got here 0.1 m cup. Can write this or moles per liter. Moles per liter. Moles per liter, or you can write moles per liter. Moles per liter. So we go to the second question. Question number 5. We have been asked to determine the mass in grams of the mass in grams of sodium carbonate in 1 liter. Of sodium carbonate in 1 liter. So in this case, of sodium carbonate in 1 liter, which is 1,000 cubic centimeters, 1,000 cubic centimeters, this is what we call of solution P. Of solution P. When you are given, if sodium is equal to 23 relative atomic mass, carbon is always 12, oxygen is always 16. So now, after you have read the equation, you must calculate the relative formula mass of sodium carbonate before you do anything else. So, relative formula mass of sodium carbonate, we are going to approach it in this way because we still have some questions to answer. So we must save that space. So we are going to ask ourselves, sodium carbonate, this is how it's written. The RFL of sodium carbonate is equal to sodium carbonate. Remember, it has a relative atomic mass of 23. But because they are 2 atoms, because of these 2, we multiply it by 2. Then we put the brackets. Then we put a plus. Then we find out how many carbonates we have. Only one. So we put plus. We open the new bracket and then we put a plus. We put a multiply. Because carbonate is only one atom, we put it 2. And then we also ask ourselves how many oxygens? Oxygens are 3. So we also supposed to give a plus here, to add a plus here. Then we put oxygens are 3. So in this case, we are going to have what? 16 atoms times 3. So we must solve these questions, that the ones that are in the brackets first, so that we can get the final relative formula mass of sodium carbonate. So in this case, we have here 46 plus 12 plus 48. 48. And if you do your mathematics properly, this one is supposed to total to 46 plus 12 plus 48. 106 grams. 106 grams. And we remember we have been asked the mass. We are supposed to determine the grams of sodium carbonate in 1 liter of that solution P. So mass is equal to molarity times the RFM. Mass is equal to molarity. Molarity times the RFM. So, in this case, we are just going to substitute. Remember, we have gotten the molarity of sodium carbonate here. So, we are going to take this. We are going to take, we just substitute 0.1 times the RFM 106 grams. 106, which is going to give us what? Which is going to give us 0. Let us do our calculations properly. 0.1 times 106 is equals to 10.6 grams. So it's giving us 10.6 grams. Another question. Determine. Now that is question number 6. Question number 6. Determine the percentage purity of sodium carbonate. So, number 6. Determine the percentage purity of sodium chloride in mixture P. Determine the percentage purity of sodium chloride in mixture P. Mixture P. So in this way, we must, the mass of sodium chloride, we must take these 12 grams here. Remember, we have been given some grams somewhere. These 12 grams, it's going to give us the mass, because we have been told to determine the percentage purity of sodium carbonate in mixture P. Percentage purity, we are going to take this mass here. Percentage purity is equals to this mass here, 10.6 over 12, this one, 12 grams. We multiply it because it is supposed to be a percentage. We multiply it by 100. So we are going to take our calculator. 10.6 times 100 divided by 12. 88.33%. So the percentage purity of sodium chloride, it is 88.3%. Then question number 7. We are being asked to determine the percentage purity of sodium chloride in mixture P. Sorry, this is supposed to be sodium carbonate. Sodium carbonate now. Sodium carbonate. Now we are determining the percentage purity of sodium chloride now. Take a note. This is sodium carbonate and this is sodium chloride in mixture P. I hope that is what the question has asked. So we are going to take mass of sodium chloride, we are going to subtract them. If we want to get the mass of sodium chloride, we must subtract these 12 grams. 12 grams minus 10.6. 12 grams minus 12.6 is equal to 12 grams minus 10.6. Okay, all these are grams. So we are going to get 12 minus 10.6, which is 1.4. 1.4 grams. So now, after we have gotten this, remember, the question is asking us to get what? Percentage purity of sodium chloride. So we are going to take now this mass that we have gotten now of sodium chloride. It's supposed to be now percentage purity is equals to 1.4 over this 12, the overall 12 grams times 100, which is going to give us 1.4 times 100, 1.4 times 100 divided by 12. So we are getting 11.6. 11.66 recurring. 11.66 recurring. So, which means it's supposed to be 11.67%. Question number 8. We are supposed to determine the molarity of the solution in terms of sodium chloride. Molarity of the solution in terms of sodium chloride. Number 8. Molarity of the solution in terms of sodium chloride. So now we are going to get the molarity. Is always mass in grams per liter. Molarity is equal to mass in grams per liter divided by the RFM. So we are going to do a substitution. 1.4 molarity, which is 1.4 over the relative formula mass of sodium chloride, RFN of sodium chloride, which is equivalent to sodium, is 23 times 1, which is 23. Then chlorine, the relative atomic mass of chlorine is 35.5. Chlorine, this is sodium, and then chlorine, 35.5 times 1, which is 35.5. So now, when you add everything, it is giving us 53.5. 53.5. So, which is going to give us, if you divide very properly, you are going to get 53.5 . You are going to get 0.02. 0.02 M more. 0.02 M. I hope that one has marked the end of our class, our virtual practical class. The next class we are going to discuss Titration Practical 5. And for those few remarks, please remember to subscribe, to share, to like, and also give some comments so that we can be able to communicate. I will be able to answer some questions that you give on the comments. For those few remarks, I will meet you next time in the next virtual practical class. Otherwise, thank you and bye-bye.